Hurricanes on bubbles sound pretty crazy, right? Well, in 2013, scientists from the University of Bordeaux in France mimicked the physics of a hurricane on a half-sphere bubble. Check this out. As they heated up the soap film from the bottom, convection along the bubble shell caused vortices to form in the film. These vortices mimic the behavior of hurricanes and cyclones in our atmosphere. I really want to make a hurricane in my kitchen, so let's do it. I'm gonna put a little bit of bubble mixture on the top of this metal cup, blow a bubble, and then turn on the heat. Now, this isn't as controlled as the original experiment, but as the bubble heats up, I'm definitely getting those hurricane-like vortices. They're so incredible. They're so beautiful. Scientists sometimes use bubbles as models for the atmosphere because they're very thin, almost flat as compared to the sphere they enclose, just like an atmosphere is thin compared to its planet. Scientists noticed that the strength of these bubble vortices would intensify and then die in a uniform way. So they thought, why don't we compare this to hurricanes and cyclones? And it turned out the life cycle of the bubble vortices closely paralleled the more than 150 cyclones that they studied. This observation could give some insight into when a cyclone in our atmosphere will stop accelerating and then die out. A pretty good use for a bubble. If you try this at home, be super careful because the metal gets hot really fast. So something else happened here. I stumbled upon a dancing bubble that lasted for 5 minutes because I initially didn't read the setup of the original experiment very carefully. We all know that bubbles are easily agitated and they pop. Why didn't this bubble pop? Well, why do bubbles usually pop even when you leave them alone? One factor is gravity. Gravity pulls the soap and water molecules down, aided by adhesion, or the stickiness between the molecules, until eventually you're left with a super thin film on the top of the bubble that eventually breaks, like a sand tunnel that gets too thin and collapses. And if there were no gravity, you'd still have evaporation. The H2O molecules leave one by one until, even in space, your bubble would eventually pop. So what's going on here? Seriously, 6.5 minutes in. So here, the heat and motion redistribute all the molecules in the bubble so that you don't get that thin film at the top. And the boiling water keeps the air nice and moist, which helps with the evaporation. So you get an everlasting bubble until it pops. Bubbles are the best. They're actually used for a lot of different types of research. In this experiment conducted at the University of Chicago, bubbles were deposited on knotted structures in water so that when those structures moved, the bubbles stayed in the middle of the resulting vortex to show crazy knotted vortices. In mathematics, researchers at UC Berkeley aim to figure out how multi-bubble systems orient themselves and derive mathematical models to determine how bubbles pop. It turns out systems with even 3 bubbles are very complicated. And of course, bubbles are just fun. Try blowing a bubble inside of your dish bubble. Just make sure that the straw is wet. And then you can walk that bubble around the plate with a balloon that you rub against your hair, which is awesome. But that's a topic for another video.